We will continue this part 2 of 6-4, completing the square, with a real problem, and we are going to use those steps we had before. So here is my equation. First step is to subtract this constant away from both sides. So I have x squared plus 4x, add 12 to both sides, equals 12. Second step says we need to figure out what number will complete my perfect square when I add it to both sides. And I get that number by taking 1/2 of the b, and then I'm going to square it and put it in both of those positions. So I'm going to write 2 squared and 2 squared. Now, this side I can combine, this side I'm going to leave alone. Then it says to go ahead and factor. Now, this will always factor. I don't even have to think about it because I made it factor this way. It's going to factor into x plus 2, the quantity squared, equal to 12 plus 4, 16. Next step says take the square root of both sides. So I'm going to go ahead and square root both sides, remembering when I do that, I always get plus and minus. And so I have the square root of something squared is x plus 2 is equal to the square root of 16 plus or minus 4. That gives me my two equations of x plus 2 equals positive 4 or x plus 2 equals negative 4. Those are easy enough to solve. Subtract 2 from both sides, x equals 2, or subtract 2 from both sides, x equals negative 6. Now if you put 2 back into this equation, it should equal 0. If you put negative 6 back into this equation, it should equal 0. So you can always check your answers in that manner. So let's go ahead and handle something where the a is not 1, and that's a key issue. The steps we've gone through only work if a is 1. When a isn't 1, we get an extra step. So we need to divide by a. So then we'll complete our problem. So the first thing we're going to do here, we'll call it step 1/2, is that we need to say x squared minus 2/3 x minus 1/3 equals 0. And remember to do everything. You have to divide every single piece by that a value. So now we are back. Step 1, I'm going to add 1/3 to both sides. Step 2 is that completing the square. So what value are we going to add to both sides that will make it into that perfect square? So we take 1/2 of our b value. Well, 1/2 times 2/3 is way less scary when we write it out. So I'm going to write 1/3 squared plus 1/3 squared. So then this side is going to factor because I made it that way. The base, a minus the base, leave the squaring off, the squaring goes on the outside, is equal to, I have 1/3 plus 1/9, make a common denominator, 3/9 plus 1/9 equals 4/9. Now my next step, I can take the square root of both sides. Because that's how I undo squaring. And remember, when I do that on the right, I get plus or minus. The square root of something squared is the something. Square root of 4 is 2. Square root of 9 is 3. So my two equations are x minus 1/3 equals positive 2/3, or x minus 1/3 equals negative 2/3. Go ahead and add 1/3 to both sides. And 2/3 plus 1/3 is 3/3, which is 1. Or add 1/3 to both sides. And x is equal to negative 2/3 plus positive 1/3 is negative 1/3. Now what happens if that b value is odd? And all that's going to happen is I'm going to have a little messier numbers. Nothing really changes. So I check, my a is 1, so I'm good to just start with my first step of adding 5 to both sides. My second step is to figure out what value I'm going to add to both sides. So here's b. So I have 1/2 times 3, which is 3/2. And so I'm just going to take and square 3/2. Then my next step, this side will factor into x, there's my base, minus, there's my base, 3/2 squared is equal to, so I have 5 over 1 plus 9 over 4, common denominator, 20 over 4 plus 9 over 4. So I have 29 over 4 on the right. So that equals 29 over 4. My next step is to take the square root of both sides, plus and minus the square root of 29 over 4. And then I can go ahead and solve those two resulting problems, which are x minus 3/2 is equal to, I can't take the square root of 29. The square root of 4 is 2. Remember, I can leave a radical in the numerator, and so I am just talking. Now I have x minus 3/2 is equal to the positive square root of 29 over 2, or x minus 3/2 is equal to negative square root of 29 over 2. Add 3/2 to both sides. I know I can't combine a radical thing and a non-radical thing, so I have x is equal to the square root of 29 over 2 plus 3 over 2. And that is your exact answer. Same thing over here, add 3/2 to both sides. And I have x is equal to negative square root of 29 over 2 plus 3/2. And that is my exact answer, and so I'm done. Now what happens if I maybe get a complex number? My process is the same. My a value is 1, so I have the simplest method. First step, subtract that c value away. X squared plus 2x equals negative 3. Second step, what value am I going to add to both sides to make that perfect square? Well, here's b, so I take 1/2 of b, which is 1, and I'm going to square that and add it to both sides. So then I go ahead and factor this side. It's going to factor into the base plus the base. X plus 1, the quantity squared, is equal to, this side equals negative 2. Step 4 is to square root both sides. X plus 1, the quantity squared, is equal to plus or minus the square root of negative 2. Step 5 is to go ahead and solve that. So I have x plus 1 is equal to plus or minus. Now the square root of negative 2 is negative 1 times 2. So the square root of negative 1 is I. I can't do the square root of 2, so I leave it as an exact. So my two problems are x plus 1 is equal to I square root of 2, Or x plus 1 is equal to negative I square root of 2. Subtract 1 from both sides. And there is your exact answer. Subtract 1 from both sides. And there is your exact answer. So it's just simply a matter of following these steps with the added 1/2 step of make sure A equals 1, divide if it isn't. And you are good to go to turn a trinomial into one of those perfect quantity squared.